Hi guys, we continue solving our task. Today we are undercover. So let's go. Our task today is design an algorithm that collects daily price quotes for some stock and returns the span of the stock's price for the current day. So the span, what does it mean? So the span of stock price in one day is the maximum number of consecutive days starting from the day and going backwards, for which the stock price was less than or equal to the price of the day. For example, if the prices of the stock in the last 4 days is 7212 and the price of that stock today is 2, then the span of today is 4. Because starting from today, the price of stock was less than or equal to for 4 consecutive days. Also, in the prices of the stock in the last 4 days is 734.12, and the price of stocks today is 8. Then the span of today is 3, because starting from today, the price of the stock was less than or equal 8 for 3 consecutive days. Okay. So, for example, okay. So we have to implement stock spanner. So initialize the object of the class, and next, with some price, returns the span of the stock price given the day price is price. Okay, so let's try to understand actually the problem. So we have function next, where we return some int price, and we should return the span of the stock's price. Span of the stock price. Stocks, right? Stock's price, yes. So what does mean the span? So the span of stock price in one day is the maximum number of consecutive days starting from the day and going backwards, for which the stock price was less than or equal to the price of the day. Okay. So, for example, if we have the prices like this, 7212, and the price of the stock today is 2, then the price of the span is 4. Because starting from today, the price of the stock was less than or equal to 2 for 4 consecutive days. Like today is 2, then 2, 2, 2, 1, and 2, and then it's 7, right? And we should return the maximum number of consecutive days. So here, for example, if 8, then 3, right? Here, for example, for 1, yeah, so we have next 101. So why? Return 1. Okay, so we are storing them. Right, so we store 100, then 80 is less than 100, 60 less, 70 less, 60 less, 75 is greater. So we return 4 because the last 4 prices equals today price of 75, where yeah, so we should like actually deduct right from, and then the next is 6. So what we can do, we can here's 4. So actually what we can do, like we can store them. I think, yeah, why do we need a stack? We can Yeah, we can just store them into the array and then just go backwards. But the problem here is that we have 10 in 4th power of calls. And if we will store for each call, it will be 10, I think, in 8. It's quite a lot, but we can try actually to implement it. So let's try to implement with just simple list. And for a simple list of integers. And then for the next price, we can just have our index. So our index would be like always equal to list size -1. And then we just have our result, which would be 1, because it always at least one element, and we return this result. And then we just go to the for loop, and we have for loop, we start like we can just go while list get I list get I is less than price. We can just increment our result by 1 and decrement I by 1. And we are going while I is greater or equal to size. So we have this next, and that's it. Okay. So, and yeah, of course, here we should add to our list our price. I think here it's greater or equal than 0. No, it's not. Okay, wrong answer here. Why? So 20e equal. Okay, so here it should be equal as well. Yeah, and we submit, but it's quite slow. And we can check that we actually can do it with stack, but yeah, I don't know like why with stack is faster. Why with stack is faster? We have stack with this one, okay. With price and span. Okay. Yeah, understood. So actually with stack we store not only value, But you see, we store, we pop from the stack, and we add as span, and then we push the next value with some span, and yeah, return. So we can just implement this. So it will be stack, new stack, and yeah, so we just have a result, and then return this result. And yeah, so here we see that while stack is empty false, and stack peak is less than price, we can we have also yeah, so here we store actually our value, so we pick and we get 1, right, where price, and we do like stack pop, and when we pop we take yeah, also 1, right, span, we take span, right, so 0 it will be price, 1 it's span, and we add the span to our result, and then here we do like step push, and we are pushing this value with price and result. Something equal. Yeah, now it here. So how it works? So we have stack, right? So first stack is empty, so we just put 1. Then it's greater, so it's not going here. So we again put 1, and we put like 1, 1, 1, 1, and then, for example, we see something is greater. If something is greater, we increment by 1, right? And we know like what is the value greater and how much value we have less, for example, than this value specific. So we just put this span or result here. Yeah, so it's very, very convenient, I think, solution. Yeah, and we can check the same idea here. Yeah, so the same idea. Great. All right, so let's make it as done, and let's go to the next one. So next one is Carfleet. Yeah, I know that, yeah, it's quite complex, so let's just stop here, and tomorrow we will continue. Thank you.